This example comes out of section 8.4, logarithmic and exponential equations. This question we're asked to solve, and we are asked to answer as an exact value and to 2 decimal places, which means that we kind of need to do this algebraically. It is possible to solve this question graphically, to graph the left side, graph y equals 6 to the x, graph y equals 131, and find this intersection. But unless you're using a really fancy computer calculator, you're going to get a decimal approximation for that answer, so you'll be able to do the 2 decimal places part, but not the exact value part. If this was powers of the same base, something like 3 to the x equals 27, we'd be able to say, 3 to the x equals 3 to the 3, so x equals 3, and use what we learned in Chapter 7 in exponential equations. This question, unfortunately, 131 is not a power of 6, so we're not able to do that either. So the tool that we're going to use here is to take the log of both sides of this equation. If 6 to the x equals 131, then log of 6 to the x must equal log of 131. They're both positive numbers. There's nothing saying we can't log them. The reason why this is such a useful tool in algebra is that we can bring this x down and say x times log 6 equals log 131. So x equals log of 131 divided by log of 6. Those are both just numbers. They're not particularly nice numbers, but with a calculator we can figure out what those numbers actually equal. But as far as exact value answer, that is the answer that we'd be looking for. It is also possible right from the beginning to say this changed into log form is x equals log base 6 of 131. That answer is just as good and actually equals the same number given the change of base identity. But if you are asked to give the answer to 2 decimal places, we do have to crunch the numbers here and say what is log of 131 divided by log of 6, and you get approximately 2.72. And if your calculator does base 6, even more direct, but you still get 2.720899433, but rounded to 2 decimal places. There you have it. So part B is a very similar question, a couple extra minor complications thrown in. There's this constant 5 out front, and the exponent is now 3x instead of x. Let's deal with the 5 first. Just divide both sides by 5, and you've got rid of that problem. 4 to the 3x equals 145. Again, we could graph it, find the two, where they intersect, but we want an exact value answer. So we're going to log this thing again, and we'll have log of 4 to the 3x equals log of 145. So 3x times log of 4 equals log of 145. Leave the x all by itself, divide by 3 log 4, and you're left with log 145 divided by 3 times log of 4. Perfectly good answer in terms of exact values. That's what you want. To get the decimal approximation, grab your calculator, and you get an answer of approximately, and again it has to be to 2 decimal places. I've got 1.19665, so I need to say 1.20. So rounded to the nearest hundredth, there you have your answer.